Now let's look at using algebra tiles to represent something that's already written, and specifically something that's represented with the distributive property. So let's say I have the following situation. 2 times x plus 1 equals 4. So I already know that this is just representing a trade in a store. So I see my 4s right here, so that's $4, 4 ones. And then over here I've got 2, but what do I have 2 of? I don't just have 2 x's or 2 widgets like normal. I have 2 of this whole quantity. I have 2 x plus 1s. So here's 1 x plus 1 right here, and then I have to put down 2 of those. So here's another x plus 1. If I arrange them, you can see there's a x plus 1, there's an x plus 1, and I have 2 sets of them. So I can see now when I lay them out like this, that what I have on each side, I have the 4 on this side, and then over here I have 2 x's plus 2. This is where this whole distributing thing comes from. I'm saying I've got 2 sets of x and 2 sets of 1s. So if I count them, 2 widgets, 2 x's, and 2 1s, or $2 here. So from here, like, this is just the same solving that we've been doing before. This would still be a fair trade if I hadn't given 2 of my dollars and the clerk hadn't given me $2 in change. So if I just take those $2 off, then I can see that I have $2 left over here and that I have 2 widgets left over here. Now, because I have 2 widgets and I want to know the price of 1 widget, if I divide this into 2 groups, then I have to divide this side into 2 groups, and I can see that each widget is just worth 1. So if I divide this into 2 groups, one widget is worth $1, right like that. And remember, the reason that I can take these off is, and still have it be a fair trade, is that if I see, now that I've divided into 2 groups, that each widget is worth $1, if I take 1 widget off here and I take $1 off here, that's still a fair trade because I've removed pieces that have equal value.